Good afternoon, everybody. Thank you for staying here for my talk. I assume you have to be tired and information exhausted by so much of interesting talks, so I will just, in this talk, try to convince you that security of your application lays just a few clicks away and how you can benefit from this situation. So let me briefly talk what we will cover. I'll try to convince you that you should care about security. I'll mention some famous breaches you might or might not be aware of. We'll briefly discuss how the security vulnerabilities are revealed and where you can check them. I'll also try to show you a vulnerable application and how we can attack it using a regular expression denial of service attack in Django. Then I'll cover tools which can help you to prevent such issues and how to remediate if any issue is found. I'll try to do quite a few live demos, so at least you're gonna enjoy me sweating here and figuring out why the hell my preciously crafted examples are not working. So a few things about me. I'm a full-stack developer, so disclaimer, I'm not like a core Python developer, so my approach to Python examples may be suboptimal, so bear with me, please. I used to work for Czech startup API, and now I moved to another startup called Snick in London. And since I'm in love with puzzle hands and guitar, you will be able to see me playing around tomorrow with all other music-friendly guys here. Few words about my company. Snick is a startup founded in London/Tel Aviv in Israel, founded in 2015, and we provide solution for addressing vulnerabilities in open source libraries. So we are not into like a static analysis or like a runtime analysis of malware or vulnerabilities. We currently have 40 employees in 3 offices in Tel Aviv, Boston, and London. And we recently closed a $7 million Series A investment. And if you would be really tired and bored by this talk, feel free to relax. And in the meantime, you can try to figure out why we are called Snick. Feel free to post your tips or come up solutions to questions form, and who's right can get some swag. Okay, let's move to the root of the talk, why you should care about security of your application. It is really easy to be forgotten, and some basic and kind of stupid mistakes can lead to serious issues, as we will talk about them in a few seconds. Prevention is usually much more cheaper than any kind of healing or remediation. And it's one of the best practices. I'm just, as an analogy, you are not leaving your house unsecured, unlocked, just because it's a repeating and tedious work to turn the lock every time. You might say that code you have written is secure because you are following the best practices and you are security aware. That's definitely true. However, if you are using any third-party libraries, you are introducing code that you might even not haven't seen. And as you'll see, even the pretty big and famous and widely used libraries can be vulnerable. So where can such a security hole can lead? In 2015, there was a famous data breach called Panama Papers. It was a breach of Mossack Fonseca, Panamanian law firm. And what leaked was detailed financial and attorney-client information for more than 200,000 entities. It brought down Prime Minister of Iceland and brought some controversy about Prime Ministers of Great Britain and Russian President. And the root cause was in vulnerable WordPress plugin. You can read more on the link provided. Just 2 years later, there was another famous breach of credit reporting company called Equifax. It exposed sensitive information such as social security number, addresses, maybe even phone numbers of 143 million Americans, and it was caused by non-patched web server. Both these leaks could be prevented if the vulnerabilities they were disclosed and which were known would be patched in a time. So in order to do it, you should try to use some tool that will help you and gets you notified about vulnerabilities when they are discovered. It should be some kind of push notification, so you get notified if any of vulnerabilities is revealed, so you can act upon that. And ideally, you should get even the remediation automatically. Let's briefly cover how vulnerabilities are revealed. There's usually some research done by independent researcher, university software vendor. So somebody discovers a vulnerability in a software, and then there are like two most common processes. One is called full disclosure, and that means it's just revealed, it's just published, and everybody is freaking out and panicking about vulnerabilities of the servers. Other process is called responsible disclosure, which means that vulnerability is revealed to vendor in private, and researcher coordinates public disclosure with the vendor. So it's usually done in a way that vendor has some time to issue a patch, to prepare for the fix, and then it's publicly revealed so everybody can act quickly. Sometimes there are like voices asking or saying that vulnerabilities shouldn't be disclosed at all because it means they can be abused and you can use to exploit the vulnerability. However, vulnerabilities are disclosed in order to be fixed, not to give anybody ammunition to exploit them. To get oriented, it's beneficial to understand a few abbreviations. The most common one is CVE. That stands for Common Vulnerabilities and Exposures. And that's basically a list of entries for publicly known vulnerabilities. There's another abbreviation called CNA, what stands for CVE numbering authorities, and that's some authority which can create a record in CVE list. So there's a global list of vulnerabilities that you can check, you can read from it, you can learn from it, and you can understand what's going on. To provide some examples of the most known vulnerabilities, you have probably noticed January this year, two big vulnerabilities were disclosed. First one was called Meltdown. You can see CVE assigned with year and with some ordinal number. So Meltdown is a vulnerability on a processor level, which allows a program to access the secrets of other programs and even the operating system. Connected one was called Spectre. It was discovered by same person. And Spectre is another example of vulnerability on a processor level that breaks isolation between applications. A longer time ago, there was a vulnerability discovered in a popular cryptographic library called OpenSSL. Vulnerability was called Heartbleed, and by exploiting this vulnerability, the attacker will be allowed to steal information normally protected by the SSL/TLS. So, what will we try now? We will try to exploit vulnerability in Django Web Framework in version 2.0.1. That's introduced using django.utils.html URLs. I'll briefly cover what does it do in a few seconds. And And we will use regular expression denial of service. Denial of service is kind of an attack that tries to bring your site down. So it won't be responding to your user request. How does the regular expression denial of service work? It tries to trick regular expressions into something called catastrophic backtracking, what basically means that regular expressions engines try all the possible combination of previous characters if they have found non-matching one, what's the backtracking part, and for long strings with non-matching character at the end, the number of steps can be pretty high, even catastrophic. It will be visible better here. So given a regular expression on the top and invalid strings on the left side of a table, you can see how many steps, the most right column, are needed in order to verify that string does not match. So you can see it grows exponentially, and with like a crafted malicious string, it can be really, really slow. And this is the first time for some live demo, so let me go out of presenting mode and bring my, just a second. So I will try to bring my editor here. Cool, I hope you can see it. So I have two really short Python scripts verifying this string against a regular expression provided in the presentation. So the first one works fine, and the second one is exactly the same except of the last character. So if I skip to my terminal and I'll bring it again to you. Cool. And maybe clear it a bit. Working on it. I tried, however, so once more, no. Oh, yeah, sure. Cool. Cool, so better, I believe. So if I will show you how the first correct regular expression works, you can see it found a match in pretty fast manner in like 0.02 seconds. However, if I switch to the second one, we will wait a bit, and we'll realize that string is not found in nearly 5 seconds. So the difference is pretty steep, and that's because the number of steps needed for verification. So, let's continue with the live demo part and try to bring down a really simple Django application using this vulnerability. Let me zoom again. So, to show you, in my requirements.txt file, I have just the Django 2.0.1, and when I run server and try to navigate to the web page, I again need to bring a bit. Cool. So I'm zooming again. So you can see there's just a big text area where can I paste any text, and what it will do, it will substitute all HTML links, or like all plain text links with HTML versions. So if I grab my string here that I have saved for this demonstration, I believe I am able to type it despite the fact it's hidden. Yes, so there is a long string with some HTML links, and when I click URLize, you can see that links are URLized in a sense, and to believe me that it's not done by a browser, I will try to navigate to it, and you can see, if it would be zoomed correctly, you should be able to see that rel nofollow parameter that's added by URLize. So what happens when we will try to provide a bad string that I have prepared? I'll try to move it here a bit. Cool. So let me generate malicious string with a lot of spaces that will trick our application for regular expression denial of service. And go back to browser, paste it here. You can see it's just an arbitrary empty string. And when I click URLize, we can wait for a long time. I realize that denial of service examples are good for talks when you are not sure whether you will be speaking long enough, because you can wait whatever time you need. But the only way what to do now is to bring the application down. So we have successfully verified that the vulnerability is really there. And back to presentation, I'll try to show you a few tricks how to check for it. I was able to find 3 different tools that should be able to help you with Python packages. First one is GitHub. However, that's not entirely true what I just said, because I was really hoping that Python support coming in 2018 will be done before this talk. Unfortunately, it hasn't happened yet, so there's still information that we are waiting for Python support. So GitHub has an internal alerting process for vulnerabilities and packages, currently supports JavaScript and Ruby only. The main disadvantage can be that it's GitHub only. So if you are using Bitbucket or GitLab, you are out of luck. And the other part is that it works only with CVEs published, sorry. So not every vulnerability has to have a CVE published. Another tool is the fresh new package management and working environment setup tool called pipenv that provides a pipenv check command, which will do exactly what would you expect, checks for security vulnerabilities. In a context of PyCon, that's fine, that's Python only, but should you have, for example, like a front-end part written in JavaScript, pipenv check wouldn't help you with other language vulnerabilities. Last tool is the one my company provides. So another disclaimer, I am biased here, but I believe the way we are doing security checks is the right one. So we are trying to cover as much ways as possible. In a sense, we support over 8 package ecosystems. We support even on-prem and closed environments. We maintain our own vulnerability DB for vulnerabilities checks. So we are not depending just on the external list, but we have also our own security research. And what might be good to mention is that we are free for open source. So another juggling with terminal here. I'll try to show you how to use our CLI tool. It's an npm package, so you would need to type npm install snic, that I already did. Then you would need to authorize with a token, that I did as well. So now we are fine to just call snic test. Query our vulnerability database, and you can see we have found 3 vulnerabilities. One that we haven't exploited, but 2 are related to regular expression denial of service. There is some information more with link to our vulnerability DB and some metadata about what just happened. I'll show you the other tool I mentioned, pip-nf check. Oh, sorry. It's pretty fast, so shouldn't be an issue. So we can see we have pretty similar output with another problematic regular expression. Back to slides. So we have identified an issue, and now we'd like to remediate it or even prevent it. What can we do here is we can set up Snic to monitor our CVS, either GitHub or Bitbucket or GitLab, and monitor for any new vulnerability introduced and verify pull requests we are issuing. So let me jump to the browser and try to connect Snic with my GitHub repository. I pushed my code to GitHub. Oh, sorry. Just let me bring browser here. So here's a code just pushed to GitHub, the code you have already seen. And this is how Snic UI look like. So if I would navigate to projects, I can easily add GitHub repositories to Snic. It will ask me to select the repositories I want to add. And we are now importing projects, and in a second I'll show you a dashboard with vulnerabilities we found. Cool, so it should have finished. We can check logged, we created a project. And when we check it, we can see we have 3 medium severity vulnerabilities with some details, with the path, how the vulnerability is introduced, and with possible remediations. What Snic is also capable of doing is to check pull requests automatically and either success or fail when vulnerability is found. To demonstrate it in a better way, let me just briefly adjust settings of the project that we'd like to fail the repository for any vulnerabilities. The other option is to fail only when pull request adds a new vulnerable dependency. So if I now try to change my manifest file in order to fix it, and I'll do that for the version that's still vulnerable, you should be able to see failed GitHub check. So let me create pull request. And you can see pending Snic check, which should fail in a few seconds. Yes, you can see there are 2 vulnerable dependencies. So I'm still able to merge pull request, but we have a failed check here. So in order to finally solve this issue, we need to update to version 2.0.3. So let me try that, and let me show you the success check and update in a code. So let's create another branch. Let's create a pull request. Wait a second or two for a green check mark. Cool. So you can see that all checks have passed. And we can merge pull request. And when I switch back to my terminal and I'll update the code, what I need to do now is to run pip install again. I'll just start it and tell you why. Because if you have installed packages, we are trying to prepare the dependency tree from your installed packages, because it's much more accurate than relying on manifest file only. So I had to install updated version in order to run sneak test and get green result. So no dependency have been found. And if I would try pip env check, it should give me the same result. Yep, cool. So we have verified the issue and we were able to solve it successfully. What was it to mention that our support for Python is not as mature as for another language. So just give you a small teaser from another languages. Currently working for Node.js or JavaScript, Ruby, and Java. We are able to issue pull requests with patches automatically. And even if the new version is not available yet, we are able to provide a custom patch for issue remediation. We can also provide like a last protection before deploying the code. So should you be running your code on Heroku or AWS Lambda, we won't allow you to deploy a code when vulnerability is found. So what I would like you to remember, please care about security from the very first beginning. It's the same thing as you are testing your code using continuous integration or any other approach. You can use tools for the similar help. And you don't have to use Snyk. There are different tools. So choose your tools for your job. And let me reveal why we are called Snyk. It's pretty easy. So I believe we have time for questions now. Do we?
We definitely do have time for questions. Can I have some questions on the screen? Or maybe not.
I can have like a slide with questions, but
there we go. All right, so we have 3 questions. One of them is an actual question. What are the differences, advantages of Snyk.io over PyPI.io, if you know that?
Unfortunately, I don't know, and thank you for bringing another tool. I'll be happy to discuss it later and see what it does. I haven't found this one when I was doing my research.
Right, thanks. So Michal is apparently the winner. So
cool.
Congratulations.
So grab me after the talk, and we agree on a swag you'd like to have.
And then we have 2 words. NPM audit.
Yes.
Can you guess what that means?
I
Because
know,
I can't.
I know what does it mean. NPM audit is another similar tool used for node package management in a Node.js world that does similar things. And it's kind of new. In comparison, if you are using JavaScript only, you can definitely use NPM audit tool. I'm not entirely sure. What I'm sure with, they are not using SNCC database, but I'm not entirely sure which vulnerability DB NPM audit uses. So if you are in NPM world only, that's definitely an option.
Right, thank you. Do we have any more questions? You don't have to go online. You can just raise your hand now. Or just find Míla in the audience later. How long will you stay here?
Yeah, I will stay here few minutes today and the whole evening tomorrow, so feel free to grab me.
Right, so any more questions, just find Míla. Thank you.
Thank you.